Welcome. Take a slow, deep breath in, hold it for just a moment, and exhale. Clear your mind completely. Settle into this deep focus strategy session. We are preparing for Cambridge AS and A-level mathematics, specifically syllabus 9709. Imagine a clean, aesthetically pleasing dark mode digital tablet interface right in front of you. Soft, rhythmic study beats are quietly humming in the background, anchoring your attention. Your personal focus level indicator reads 100%. Today, we are calmly and methodically unpacking one of the most critical architectures in the entire syllabus, differentiation. More specifically, we are going to master the derivative of x to the power of n and the incredibly powerful chain rule. I am your guide. Think of me as your personal exam strategist. Together, we are going to approach these complex structures and multi-stage problems with total, unshakable clarity. We are going to permanently strip away that heavy exam anxiety, and we will replace it with a deeply calculated, highly articulate, and beautifully minimalist strategy. There's no need to rush. There is no need to panic. We have all the time we need. Let's begin the mindful scan of exactly what the examiners are asking of you.
Look closely at this statement. This is direct feedback from a senior examiner. It reads, "Mastering differentiation is essential for Cambridge mathematics. This topic appears in every examination series." This isn't just a casual observation. This is our ultimate validation. It openly acknowledges the undeniable absolute weight of this topic. Differentiation is not something you can just bypass, skim over, or cram the night before. It is a foundational, load-bearing pillar of the 9709 papers. Okay, let's dive into this with serene confidence. We're going to decode exactly what the examiners actually want to see on your paper when they're deciding to award those top-tier A-star marks. We are moving far past the sheer sudden panic of seeing a highly complex derivative problem sitting there on page 3 of your exam booklet. Instead, imagine taking a clean digital highlighter and calmly peeling back all those intimidating filler words, isolating the exact assessment objectives demanded by Cambridge. We are finding the signal in the noise. Here is our pristine roadmap for systematic clarity today. First, mastering core math principles. Second, the procedural framework. Third, deconstruct, solve, evaluate. And finally, avoiding examiner pitfalls. Let's move smoothly into the first phase. Phase 1. Mastering core math principles. Building the foundation. In the specific context of differentiation, the Cambridge syllabus explicitly emphasizes that top-performing students exhibit a deeply connected conceptual understanding. This means your mathematical knowledge absolutely must be transferable to completely unfamiliar contexts. Listen closely to this. When Cambridge throws a bizarre, highly contextualized word problem at you, maybe something involving the volume of an expanding weather balloon or the surface area of a melting ice cube, they aren't just testing if you memorized a standard formula. No, they are testing if your theoretical foundation is solid enough to adapt gracefully under pressure. And there are exactly 3 cognitive domains targeted by the assessment objectives to measure this. Just 3. Domain 1, knowledge and understanding. Domain 2, application. And Domain 3, analysis. To truly conquer those 3 domains, you cannot just indiscriminately drop numbers onto the page hoping something sticks. You must systematically show the examiner that you deeply understand what the derivative actually represents. You have to demonstrate how to seamlessly apply the x to the power of n rule mechanically. And then, you need to show how to analyze a multi-layered, nested function where the chain rule must be carefully invoked. It is a precise, beautiful triad of cognition. Know it, apply it, analyze it. We decode the command words first. If a question asks you to evaluate, it requires a different structural approach than if it simply says solve. A calm, structural approach to paragraph and layout planning right at the start protects you from running out of time later. The theoretical architecture of this entire mathematical topic rests on very precise definitions and clear causal relationships. When we look at principal examiner reports across multiple years, they continually highlight one beautiful, undeniable fact. Candidates who reference cross-topic connections achieve significantly higher marks. Think of your syllabus as a vast, interconnected web, rather than isolated islands of information. Differentiation simply does not exist in a vacuum. It integrates heavily and beautifully with other syllabus areas. We're talking about coordinate geometry, kinematics, and optimization. When you are writing out your exam and you suddenly recognize that the complex derivative you just found using the chain rule is actually representing the exact gradient of a tangent line to a curve at a highly specific coordinate, that is the moment everything clicks. You are forging those exact cross-topic connections. You are building a sophisticated web of mathematical reasoning that Cambridge examiners actively and generously reward. It's about seeing the bigger picture with total clarity. Now let's visualize a shared, serene digital workspace. I want you to picture two scholars working together on a high tariff past paper question. We'll call them Alex and Sam. Now, Alex is highly analytical, incredibly precise, but Alex has a slight habit of crowding the page layout with unstructured facts and skipping steps. Sam, on the other hand, is highly creative and dynamic, but sometimes loses focus on the specific parameters of the examiner's command words. Together, they are learning the ultimate secret weapon, the method mark strategy. This concept completely reframes exam anxiety into an impenetrable shield of confidence. Academic benchmarks for differentiation require logical, structured reasoning above all else. The assessment framework prioritizes analytical depth over superficial breadth. So what does this actually mean for Alex, Sam, and you? It means you earn significant points simply by demonstrating logical, step-by-step mathematical processing, even if you make a tiny human arithmetic slip at the very final line. Examiners desperately want to see your brain working on the page. They want to see you calmly state the outer derivative, gracefully multiply it by the derivative of the inner function, and show your clean, beautifully spaced layout. Method marks are literally your safety net. They are the tangible reward for your structural discipline.
Phase 2. The procedural framework. Let's establish our standardized sequence. This is the exact moment where we transition from purely understanding the underlying theory to the rigorous physical execution on the exam paper. Here is the pristine 5-step standardized sequence for processing complex differentiation and chain rule problems. Picture Alex and Sam debating the structural framing of their argument blocks right now. Step 1. Identify key elements. They use a clean mental highlighter to peel back the filler text, isolating the exact mathematical function to be differentiated. Step 2. Apply relevant principles. Alex systematically asks, will we need the standard power rule here, or are there nested functions requiring the chain rule? Think of the chain rule exactly like calmly peeling an onion. You meticulously differentiate the outside layer first, leaving the inside completely untouched, and then you multiply all of that by the derivative of the inside layer. It's a rhythm. Step 3. Execute analysis with clear working. This is where Sam ensures every single line of algebra flows logically and beautifully to the next on the page, no erratic jumps. Step 4. Verify results. They pause. They take a calm breath. They actively check their positive and negative signs. They check their fractional exponents. Step 5. Present in appropriate format. Practical high-scoring application means using the absolute correct terminology and formatting your final algebraic expression exactly as the initial command word demanded. They challenge each other's layout choices smoothly, writing out their sentences live in the workspace to perfectly fit the mark scheme parameters.
Okay, let's just pause the smooth on-screen handwriting animation for a second. Let's breathe and refocus. Check your posture, relax your shoulders. Before we write out our final top band structural response, make sure your daily study dashboard is complete. I want you to subscribe to Ace the Exams at the handle Ace the Exams right now and enable all notification alerts. Visualize a clean, minimalist graphic of a notification bell quietly lighting up. Whether your target is an IGCSE, an O-Level, or a Cambridge AS and A-Level A-star, this channel is your weekly serene space for stress-free exam mastery. Now back to our digital workspace. Our scholars Alex and Sam have just encountered a structural roadblock mid-calculation, where their algebraic evidence drops out of alignment. Panic starts to set in. But we don't panic. We introduce a clear, visual structural framework, like the Peel structure for written arguments, applied here to mathematics. Point, evidence, evaluation, link. We smoothly and calmly restore balance to the text. Remember, skipping steps in your working out to save a few seconds of time is a common but utterly fatal trap. The framework prioritizes depth over breadth. You must map out those textbook definitions step by step and ensure there is a clear, logical, evaluative link right back to the original prompt. Deep, structured reasoning is the true metric of academic benchmarking here. Write your mathematical lines out deliberately. Fit the parameters perfectly. Do not rush. Go deep. Show the examiner every single beautifully oiled gear turning inside your mathematical machine.
Phase 3. Deconstruct, solve, evaluate. How we interpret and process the core data.
Welcome to the Visual Satisfaction Practice Arena. Let's try Challenge 1, the Mindful Scan. Imagine I'm displaying a highly complex Cambridge text excerpt or a multi-layered equation right in front of you. A beautifully minimalist circular graphic is quietly counting down from 60 seconds. Your goal is to extract the single most high-yielding core trend without letting your heart rate spike. When faced with a complex chain rule problem involving messy fractional exponents and negative indices, the most common human error is to panic and start dropping memorized derivative rules completely randomly onto the page. We call this unstructured fact dropping. It is chaotic. It causes your structural discipline to immediately break down and your hard-earned marks hemorrhage away. We absolutely must replace that panic with a calm, highly calculated identification of the given information. We systematically deconstruct the prompt. We solve the algebra with absolute surgical precision. And finally, we evaluate the mathematical outcome to ensure it aligns with reality.
Now, for challenge 2, the imperfect answer. Picture a flawed student calculation displayed on your screen. We need to identify the exact line where structural discipline breaks down and marks are lost. Problem solving in advanced differentiation strictly uses this 4-point framework. First, break the problem into clear, logical steps. If you have a composite function, bring back our onion analogy. Calmly write out the letter u equals the inner function. On the next line, write down du dx. Then write your main function y strictly in terms of u and write down dy du. It looks so clean on the page. Second, solve systematically by mathematically multiplying them together exactly as dictated by the chain rule formula. Third, check for reasonableness. Does the final degree of the polynomial actually make sense after the process of differentiation? Did the power decrease as expected? Finally, make justified recommendations or conclusions, especially if the question asks for the specific nature of stationary points. Is it a maximum, a minimum, or a point of inflection? Each of these beautifully structured, highly logical steps acts as an ironclad anchor, systematically securing those crucial method marks we discussed. I am mentally drawing clean highlighter strokes over these steps to reveal the correct paths, detailing examiner compliance line by line. Very often, higher-level differentiation problems cross over into real-world application, requiring you to extract data from lengthy texts or complex tables, interpret hidden relationships, and draw completely evidence-based conclusions. If you were ever asked by Cambridge to compare mathematical models or to compare the gradients of curves at different coordinate points, remember this crucial rule. Comparative analysis strictly requires identifying similarities and differences. You must use explicit phrases like is greater than, demonstrates a steeper gradient than, or shows an accelerated rate of change compared to. These are your comparative connectives, and you must support every single comparison with hard numerical evidence derived directly from your derivative calculations. You have to draw firm conclusions about relative importance. It is a mindful, deliberate scan of the data, effortlessly extracting the single most high-yielding core trend and articulating it as smoothly as possible. Phase 4, avoiding examiner pitfalls. This is where we lock in your grade. We have successfully decoded the command words, we have firmly established our step-by-step mathematical flow formula, and now we must armor our work against the most common, statistically proven errors that Cambridge examiners see year after grueling year. We are actively adopting the examiner's lens to safeguard your marks. Principal examiner reports reveal that candidates constantly, routinely, confuse key terminology. The absolute golden rule here is to always define terminology before using it in extended responses. If a specific question asks you to analyze the rate of change of a volume, ensure your layout clearly, explicitly defines that the derivative, let's call it dv over dt, actually represents that instantaneous rate of change before you begin any number crunching. Building this immediate, visual safety net on your page proves unequivocally to the examiner that your conceptual framework draws on deeply established principles and rigorous, evidence-based reasoning. Understanding the top 3 mistakes extracted directly from the principal examiner reports for this exact 97-9 syllabus topic is absolutely critical to your success. Mistake number 1, examiners report that students frequently confuse cause and effect in differentiation. They mix up the sequence of the chain rule, multiplying the wrong derivatives together in a rush. Mistake number 2, students completely forget to check their format and presentation at the finish line. They do all the hard work, but then leave their final algebraic answer as a chaotic, unreadable mess of unsimplified negative and fractional exponents, especially when the question prompt explicitly asked for a specific layout, like a over x squared. Mistake number 3, answers are simply not specific to the context given. If the derivative you just calculated represents a physical, real-world quantity, like the velocity of a particle, leaving off the standard units, or failing to interpret a negative sign as a change in physical direction bleeds unnecessary marks. We do not make these mistakes. We are mindful. We are precise. Let's look back at the completed, entirely flawless response architecture we've built together in this session. Your focus meter is totally maxed out. We have successfully distilled this entire masterclass into 3 core, unshakable focus pillars. Pillar 1, the 3-step question scan, where we calmly decode the prompt. Pillar 2, the marks per minute flow formula, which dictates our methodical, step-by-step algebraic layout for perfect timing and guaranteed method marks. And Pillar 3, the final polish review pass, where we consciously avoid those top 3 Cambridge Examiner pitfalls. So as we wrap up this deep focus session, I leave you with this calm, high-impact challenge. How will you apply the Deconstruct, Solve, Evaluate framework to your very next past paper? I want you to take this mindful, deeply focused framework directly into your next study session. Now subscribe to Ace the Exams at the handle Ace the Exams. Click that minimalist notification bell so you are ready for our future focused deployments. And before you log off, leave a comment below identifying the specific subject, the tier, and the exact target grade you are currently meditating on. Keep your focus deep, keep your breathing steady, and keep your working crystal clear. You've got this.